Okay, hey, let's continue on with our Chapter 5, Section 2 discussion on integrals of natural logs. We will pick up some trig functions today. I'm focusing on this day 2 where we're going to integrate some trig functions, and some of these are ones that you haven't seen before. I'm going to skip over this and just save ourselves some time. You have this trig table on reproduced on your notes, and we are real familiar with these derivatives, no problem there. And there are a lot of the antiderivatives that you know. You know the integral of sine is negative cosine, because if I look at whose derivative is cosine, it's sine, right? And so it goes back and forth. And then you hit these oddball ones. These oddball ones, right, like tangent. And you're like, well, what's up with that? I've not seen the integral of tan. And when I think about it, and I think about whose function is a derivative giving me tan, I look over here and I don't see anything that just shows tangent. It never exists over there, does it? So that makes going backwards a little bit more difficult. So I'm going to show you how we develop this antiderivative for the integral of tan. And another weird one, the cotan one, and another weird one, the secant one, and the other one that we're focusing on today is the integral of cosecant. And we'll try to develop how to get their integral so that you don't have to find it over and over, although you could if you got stuck. So let's proceed. Find the formula for the antiderivative of tangent. Well, the antiderivative of tangent could be rewritten as sine x over cosine x. Use the identity about tan. And if you think about it, this is looking lovely. Let's let u, whoops, I thought I had that. Let's let u equal cosine. Let it be the derivative or the denominator. Take the derivative of each side, and oh, that's some disappearing ink, I guess. And so is that. Let me get this straightened out, guys. All right, so let u equal cosine of x, and then du is equal to the derivative of cosine is negative sine of x, and then this would have been a du with respect to x, so we'll bring up our dx. And I have sine x dx over here, so I want negative du to match my sine of x dx. Go back over, let's replace, and we'll have the integral of 1 over u for the cosine. And sine x dx is a negative du for replacement. This gives us negative natural log absolute value of u plus c. But that's equivalent to a negative natural log. Instead of u, we'll replace it with our cosine. And there is what you saw up on the chart earlier. There's negative natural log cosine of u for tangent, and we just found it. Now, there is one other way that this can be expressed, and that is if I were to take this negative and bring it back up. Then this is going to look like natural log of absolute value of cosine x raised to the negative 1 power plus c. But we know that cosine in the negative 1 is like 1 over cosine, and 1 over cosine can be restated as natural log of secant x plus c. So indeed, sometimes you will see that that this is sometimes used as a statement for the integral of tangent, where you get positive natural log secant. This is also acceptable. So be ready and understand that there are two potential answers there. The next one I want to prove out the integral of secant x, and the way to get this one started is to multiply. Multiply by a secant x plus tangent x, and now I don't know, I'm kind of hoping this is like a big fancy 1, isn't it? And that makes it just fine to do. But how is that helpful? Well, you'll see here in a minute. Let's update our integral. We'll have secant squared x plus secant x tangent x over secant of x plus tangent x, and then multiplied by dx. This should have a dx. And you're saying, wow, that looks complicated. Well, let's let our instincts take over and set up a u sub. Let's let u equal the bottom, secant x plus tangent x. Then the derivative of that would be, the derivative of secant is secant x tangent x. The derivative of tangent is secant squared x dx. And would you believe, we need parentheses here, would you believe that we have a match here? This matches perfectly with that, just different order, but we know we can communicate the addition property. So this is nice, this is perfect. Integral 1 over u, that's our secant x tangent x. The du goes in place of secant x dx. So I get du, and this gives us the integral of the natural log of u plus c. Replace u, and look what pops in, secant x plus tangent x plus c. And if you sneak back to that chart, you would find where's secant right there. Natural log, absolute value, secant u plus tangent u plus c. We just proved it out. Now those are a little bit more difficult to memorize for sure, and I think that is something that you're going to want to memorize, because solving them is not, solving that one especially is not the easiest. You would have to remember that this is kind of the trick to get things rolling, multiplying by that. Okay, cotan. Cotan can be proven out quite similar to tangent. We know cotan is cosine over sine x dx, and you would let u equal sine of x, du would equal cosine x dx, and we could replace du for cosine dx, and sine is u. This is a 1 over u, so we get natural log absolute value of u plus our c. Replace u, and we're looking at the natural log of sine x plus c. So there's your integral for cotan. I find these easy to remember by thinking about, for cotan, what's on the bottom? Well, what's on the bottom is sine, and what turns out to be its integral, natural log of sine. Same thing's true for looking at tangent. What was on the bottom for tangent? The integral of sine x over cosine x dx. Well, the answer turns out to be negative natural log cosine x plus c. What was on the bottom? Cosine. What's in your natural log? Cosine. That's one way I keep them set straight. Let's see. We've done that. So working with the integrals. Now, assuming we know what the integral of tan is, we know it is negative natural log cosine. What do I do with this 3x? Well, I use a little u sub. So let's let our u equal 3x. Then du is equal to 3 dx. Then 1/3 du is dx. We're pretty fast with our u sub these days. All right, so that's going to give me the integral of tan of u, because I replaced 3x with u. Dx comes out to be a 1/3, put it out front, du. Now all I have to know is I have to remember what's the integral of tan, and we just kind of memorized that. It is negative, negative natural log absolute value of cosine of u plus c. And don't forget, I had this 1/3 out front, so I'm going to squeeze that right in front there and get negative 1/3 natural log cosine of u, which is negative 1/3 natural log cosine of 3x plus c. There's our answer. If it's not a simple x, then it's going to involve a little bit more, and a u sub probably will be necessary. So let's let u equal 4x plus 2, because then I can turn this into a cosecant of a simple structure inside just u. Let's see what du and dx do here. We get 4 dx, but we just have dx, so we need a 1/4 du to match up with our dx. So coming back over here, we've got cosine u already is settled on. Dx is a 1/4 du. The integral of cosecant, you may want to take a peek at that chart. I'm going to scroll back. Oh, I see I've got it right here. Table. We wanted cosecant, didn't we? Right there. It's a negative natural log cosecant u plus cotangent u. You remember that? Okay, it's a negative natural log absolute value of a cosecant of u plus a cotangent of u plus our c. We need to replace these u's. So negative 1/4 natural log, it's going to get long, isn't it? Cosecant of 4x plus 2 plus a cotangent 4x plus 2 plus our c. Beautiful. I'm going to hit erase to go on to the next problem. Number 4, it says try using a trig identity. Well, I know you were good in pre-calc, and there were these identities called the Pythagorean identities for the trig functions. Let me start you off with one, see if this rings a bell. Sine squared x plus a cosine squared x was equal to 1. Another one was 1 plus tangent squared x was equal to secant squared x. Ooh, 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 ooh. That's what we have. But let me finish this so that you get these written down. 1 plus cotangent squared x was equal to a cosecant squared x. It is good to know those three. Hopefully those kind of stick with us. All right, we said we kind of hit the jackpot right here. 1 plus tangent squared x equals secant squared. So what we can do is we can trade this out. Let's exchange 1 plus tangent squared for a secant squared x over a secant x. See where this is going? And simplify secant squared over secant leaves me secant x dx. Do I know the integral of secant? I think I do. It is natural log absolute value of secant x plus tangent x. If you don't quite remember it, look on the table, it's there. Problem is solved. All right. The next one. I don't know if we really have a trig identity we want to use. I think it's more going to be a u sub on this one, actually, because I don't know of a trig identity that gives me cosecant cotan. But I do know that the derivative of cosecant is a negative cosecant cotan. So I think a u sub is in order on this one. So let's let u equal cosecant x plus 2. Follow through with our derivatives. Du dx is going to be a negative cosecant x cotangent x, and the derivative of 2 is 0. All right, so that gives us, oh, now checking back across, I don't need the negative, do I? So a negative du is comparable to a cosecant x cotangent x times dx. Trade things out over here. We are in the substitution mode. 1 over u, because our u was that, and the derivative gave us a negative du to replace the cosecant cotan dx. Okay, this is pretty nice. The negative natural log absolute value of u plus c Easy. Negative natural log u gets replaced with a cosecant x plus 2 plus c. Okay, final problem number 6. Addition and subtraction of terms within an integral allow us to separate these up. This should have had an extra set of parentheses there. All right, so we're going to get the integral of cotangent x dx plus the integral of sine x dx. We can treat them separately. The integral of cotan, remember my hint, cotan x is like a, that's a lie, a cosine x over a sine x. So this becomes a negative natural log absolute value of sine x plus some c. The integral of sine is negative cosine x plus some c. And that gives me negative natural log of sine x minus cosine x. Add those c's together. Think of c1, c2 come together to make c. One thing's bothering me. Is that actually a negative? Let's look at this. I may be wrong. What were we trying to do? It was the integral of cotan. The integral of cotan. Ooh, I was. It doesn't involve a negative. Once I got going on that, it was like, I'm pretty sure that didn't need to be negative. There we go. It is a positive natural log sign. All right, that was pretty fast. Hopefully you catch the drift. Working with trig functions really is not that much more difficult than working with, other expressions like polynomials. So why don't you give this homework on page 338 a try, and see you in class.